So our agenda for today, we'll be covering an introduction to the Aurora Nephelometer, followed by the various options, accessories, and how they can be used with integrating the nephelometer into your system. We'll then have a section on the aerosol conditioning system, an introduction to that and how it can integrate with the Aurora Nephelometer. So firstly, introduction to the Aurora Nephelometer. For those of you who haven't actually dealt with the Aurora Nephelometer, these is what the main two variants of the nephelometer look like. Essentially, it comes in three main variations. The Aurora 1000 is primarily used for visibility, measuring scattering at a single wavelength, usually green for most visibility requirements, but it can also be in the red or blue if it's ordered that way. Then we have the Aurora 3000 and 4000, which are generally used in the more research applications, which the 3000 has three separate wavelengths simultaneously and backscatter, whereas the 4000 adds the ability to have the full scatter as well as 17 extra angles within its measurement cycle. So we'll go into a bit more detail in that. And for that, I shall pass over to David Logan to give some more detail on how the nephelometer works. Thank you, David.
Well, thank you, Grant. It's nice to be here, and we're going to just briefly discuss how nephelometers work in general. In the Aurora, it's the ambient air is transferred into the optical cell where it's illuminated by a high-intensity pulsating LED light source. And this light source passes through a opal glass diffuser, which gives its unique Lambertian distribution. And the arrangement of the light source with the photomultiplier tube allow the light that's scattering onto the sample air to be detected by the photomultiplier tube, and then it gives us an intensity reading in relation to the amount of particulates that are in the optical path there. We also have a backscatter shutter that moves in and out of the optical path of the light source, and that changes the integration angle of the nephelometer. In our measurement cell here, we can see where the light source is in orientation to there's a reference shutter, the photomultiplier tube at the end, and a light trap. And this narrow optical path is where the sample is illuminated, and it gives the nephelometer the ability to pick up these small amounts of scattering that are detected there. If we look at the Aurora 3000 and the Aurora 4000, they both have three wavelengths of light. There's 450 nanometers, 525 nanometers, and 635 nanometers being the red. But the difference between the two is that the Aurora 3000 has just two angles of scattering for zero or full scattering and 90-degree backscatter, whereas the Aurora 4000, as you can see on this graph, it has 18 different angles that can be selected by the user, and they can sequentially go through each of those angles, measuring the scattering of the sample there. If we look at the light source and the main features of our light source there, the LED light source has the advantage of being very robust and providing a high reliability. In fact, we guarantee our light source to last for 3 years, but most last a lot longer than that for sure. Also, the heat generated by the LED light source is a fraction of what is generated by flash lamps that have been used previously. And the other advantage of having a LED light source is that it emits light in a specific wavelength, and so there's no need for additional filters or additional photomultiplier tubes. And also we have a servo motor here which precisely moves the backscatter arm into its precise location depending on the measurement of integration that you want to complete. Well, now we know, since we know a little bit about how it works, now let's see where the Aurora Nephelometers are used around the world. Thanks, Grant.
Thank you, David. So nephelometers are used in a large number of different applications. I guess I'd just like to cover tonight, just very briefly, a few different examples of where they are used at the moment to give you an idea of the breadth of application. So the Aurora 1000 is used in a lot of visibility requirements for various environmental pollution authorities around the world. Essentially, it measures and reports visibility, usually at that 550 nanometer range, and within Australia in particular, there's a standard, so it's used in a number of different states for the local EPA monitoring and reporting, but it is globally used in a number of countries for visibility reporting. It's not just ground-based. The nephelometer has been incorporated into a few different aeroplanes at different points over the years. This particular example is, I think, of the one from the UK Met Office. You can see it's been integrated into the actual shell of the plane there in the front. And in this case, as an example there, when a number of airlines were shut down with a volcano in Iceland a number of years ago, that plane was still able to run and take measurements through some of those plumes, including using the scattering measurements from a nephelometer. So that nephelometer has been tested to essentially pressures of the equivalent of flying at an altitude of 15,000 meters. Back on the ground, or more to the point, the ocean, nephelometer has been used on a few different ships. This particular example here was from the Acoem campaign in the Mediterranean and the Middle East. But another example here, it was on the CSIRO's investigator ship on a trip down to Antarctica. It's in use in a few different permanent stations in Antarctica. So, I mean, if we're looking at the differences from an aeroplane with very low pressure at high altitude to the freezing cold of Antarctic, the movement of a ship, clearly the nephelometer can run in a number of different locations and under quite significant different levels of measurement conditions. Another application that's typically used is for dust storm. In particular, the Gobi Desert, there's a lot of dust storms move across China, so there's a whole monitoring network there, which is an early warning system. Provides details of visibility, but also helps for asset protection and climate research. So they've expanded that network for those sort of things. Typically around the world, in areas where there is a dust storm, most filter-based measurement systems fall apart because the filter gets loaded and you stop getting measurements. The nephelometer can read some very high measurements for quite a period of time. It might need a clean out the next time somebody's out there, but you'll continue to get readings of scattering well after most instruments have stopped reading in a dust storm. Another application here in a more pristine environment. So this is an example of the nephelometers sampling from various elevations in the Amazon Tall Tower Observatory. Again, the story there is more interesting as to how the instruments get out into the middle of the Amazon and that side of things. But again, the nephelometer is a relatively rugged instrument. The Aurora Nephelometer has been used in a number of high altitude stations in the Himalayas, the Andes, the Alps. So generally these applications are often above the planetary boundary layer, so they're pretty pristine environment. But on occasion with things like a sub-Saharan dust episode where you get winds blowing particulate from Africa up over the Alps in Europe, you can certainly see the change in composition when you're using the 3 wavelength aspects of the nephelometer to look at the source of those particulates. So I've given you just a touch of some of the applications for the Aurora, it should be pretty clear that there's a number of different requirements as to how that might be integrated. So I'd like to pass over to David to go through the various options and accessories we have available to assist with that.
Thanks, Grant. Well, there are a number of options available for the Aurora Nephelometer, but when you're deciding to purchase a nephelometer, you need to decide, well, what is your application? So for the Aurora 3000, your application might be for full scatter and backscatter measurements for aerosol research, or you might need data to assist in the calculation of a single scatter albedo and also aerosol symmetry factor. For more advanced calculations and measurements. The Aurora 4000 gives you the opportunity to assist in calculations of optical depth and also the phase function. Also, another unique feature of the Aurora 4000 is the possibility to correct for truncation error within the nephelometer. Another question you need to consider is, well, what is your environment? Is it a pristine environment like in the Antarctica, or is it a densely populated environment where the particulate levels could be quite high? Or is it a remote location where maybe you just need solar power or minimum power consumption as possible? Or are you integrating it into a large research station where it might be operating with a number of other aerosol-related research instruments? There's also the opportunity, maybe you're using it in like we saw in aircrafts, or some other situations which you may need a high level of reliability. And also, if you're using it in conjunction with the aerosol conditioning system, well, we're going to discuss that a little bit later also. So let's firstly look at the standard Aurora 3000 and 4000 configuration. This is a standalone situation where the sample inlet is drawn into the cell through its internal sample pump. It's just a low power blower motor. It has 5 to 15 litres per minute, but unfortunately that flow is not regulated or controlled, so restrictions in the inlet can affect your flow, but it is good for low power consumption. And also the calibration gas is vented out the inlet as well as out of the exhaust. This is the simplest configuration. If you're in an environment maybe where you're connecting in parallel with other instruments for aerosol monitoring, where they have their own fixed flows and you don't want to contaminate them, then you could use the automated ball valve option, which can be fitted to the Aurora Nephelometers. And what this option does is, during sample, it allows the sample to go through the cell and vents out the exhaust. It uses an external pump, and it has a fixed flow of 4.5 litres per minute. And then during calibration, well, the inlet flow doesn't change. It just is bypassed out to the exhaust pump, whereas the calibration gas internally goes through the cell and then it vents out the other ball valve. So that way there's no contamination in your inlet with the other instruments there. So it's good for use in applications where you're sharing a common inlet with other instruments. This option can also be retrofitted into existing instruments, or it can be fitted in your instrument when it's new in the factory. It also requires an external pump, and we've got some more information on that at the end of our presentation, a special offer. Also, to step up a bit further, you could have the MFC and ball valve option. This is basically the same as the ball valve option, whereas internally there's a mass flow controller installed, which is programmed and controlled by the Aurora Nephelometer itself through the front menu. And you can set your flow between 0 or 10 litres, or you can have 0 to 20 litre mass flow if you desire. This option can only be factory fitted, but it's very good for situations where you've got to match up your flows with other instruments where you're using a common inlet in your system. And here's a picture of an example of an instrument we set up. It was a Aurora 4000. It was designed to go into the fuselage of an aircraft. We had to test it up to 15,000 meters using our pressure chamber to simulate those conditions. And we made the case a bit smaller. And it just shows how Ecotech can provide the right solution for whatever your research campaign may be. So we're going to look at a bit of data storage and collection, and we might hand over to Grant now for that.
Thank you, David. So obviously a key part in using any instrumentation is to be able to collect and use that data. So Ecotech has a couple of different options to be able to do so. The nephelometer has been designed so that our Aerodis software can collect directly from it. Essentially, there's a free version that comes with the nephelometer, and the more advanced version that lets you do a few more automated things. But essentially, you can collect directly from the nephelometer, or if you've got multiple things you're wanting to log, potentially the Congrego data logger can talk straight to the various nephelometers and then to Eridis. And in the example there on the screen, we can see the traces from one of the polar nephelometers at a whole stack of different angles. You can see there's a whole heap of different data, and obviously increasing as you get greater total intensity. But we've got a few different options there to be able to communicate with both the nephelometer and whatever other instruments you may need in the system. David's covered a number of the different options. There's a list here, and so in the Ecotech brochure, which can be downloaded from our website, there's a full list of the different options and which nephelometers they're applicable to. There's also a list, if you noted there was a few different references to papers. There's a full bibliography link within the at the website to also view those various the details if you're wanting to look at papers. There's a lot more than we can cover in this presentation, obviously. So one other, you could call it an accessory, you could call it a measurement, a system to work with our nephelometer, is the aerosol conditioning system. And I'd like to pass back to David to go into some more detail on the aerosol conditioning system.
Thanks, Grant. So the hygroscopic properties of atmospheric aerosols are an important parameter to assess in order to accurately model the effects of aerosols in the Earth's radiative balance. And so when certain aerosols are exposed to high humidity conditions, they appear to grow in size, and the amount of growth depends on the composition and the size of the particular aerosols. And this can be measured by exposing the aerosol to different levels of humidity and then measuring its scattering properties. So we might have two instruments in parallel. One measures the dry, unaffected aerosols, and the other can measure the scattering properties of a wet or a humidified sample. And the scattering light enhancement factor is attained by dividing the wet scattering by the dry scattering measurement. And the ACS can do this by simultaneously controlling two channels, a wet channel and a dry channel, with the ACS 1000 aerosol conditioning system. And what it's able to do is it can control the wet channel to different levels of humidity whilst maintaining the dry at a level usually lower than 40% humidity. And then it can control the flows of both channels. And then at the end of the bottom of the ACS, you can connect two aerosol monitoring instruments such as the Aurora Nephelometers, and there you can measure the scattering properties and calculate the hygroscopic growth of the aerosols in real time. Just looking at the inside of the nephelometer, not the nephelometer, sorry, the aerosol conditioning system. It's made of stainless steel, electropolished stainless steel, and the inner diameter is quite a large 41 millimeters. So that makes sure that there's a minimum of loss, particle loss through the system, and also allows plenty of time for the aerosols to take up the water vapor and to change in their size and state through the system. Each system can be easily connected or reconfigured depending on the type of measurement that you want to do. Also, at the top of the ACS, there's a motorized ball valve which can bypass the sample of your inlet, bypass it away from the nephelometers and the ACS so that you can perform maintenance without affecting any other instruments that are in the system. Some of the main components of the ACS 1000 is its main front panel. There it's got a LCD and a keypad, so you can set up points and sequences, so you can program your humidograms for whatever period of time that you like. It's made of a anodized aluminium rack, which can be which is modular, so it can be pulled apart for easy transportation. And it also has adjustable shelving so that it can be suited for different types of aerosol instruments. There's also 3 mass flow controllers on the ACS 1000. 2 of them are to control the wet and dry channels, and 1 is to control the dry purge air for the dryers. If you're using Aurora Nephelometers in, as you can see in the bottom of this illustration here, the flow for these is controlled by the ACS, and the ACS comes with its own external vacuum pump for this. So when you're configuring the ACS, you have a number of different modules. There's the Humidifier Module is one module that you'll need, and that module is what is used to control the humidity of your sample. For example, you can see here on this inner tube, our dry sample comes into the humidifier. It passes through a Gore-Tex membrane, and on the outside of that membrane there's a water reserve of high purity water. And this water is heated, and the amount of heat generated into that water controls the amount of water vapor that is transferred through the membrane and into the sample in the inner tube, hence it's humidifying your sample. At the bottom of the tube there's a precision temperature and humidity sensor, which is fed back to the microprocessor, and we can accurately control each point of humidity that you want to set in your program. For the dryer module, that sort of works in the opposite way, with similar size to the humidifier. The inner tube is covered with a Lambertian membrane, and then on the outside of that membrane is a purge air, a dry purge air, which removes the moisture from the sample of the going into the inlet. Once again, there's a precision temperature and humidity sensor at the bottom of the dryer to measure its humidity as it comes out. In some situations where the environment is very humid, you may need additional dryers. So this is a more cost-effective dryer that can be put in series with the other ACS dryers to increase the amount of drying efficiency of your system. As well as the other modules, we have an extender module, which doesn't do much. It's just a solid tube, but it extends the length of the path for both channels, so that the sample, when it reaches the nephelometer on your wet and dry side, the sample path is the same, so they both reach at the same time. So when you're calculating your enhancement factor, you know you're using data that's in the same time frame. There's also a flow splitter which divides the inlet flow into the two channels for your wet and dry, and this is designed for minimum particle loss. At the bottom of the ACS there's the instrument rack, which is an optional accessory, and that's designed to comfortably house 2 Aurora Nephelometers, but you can also adjust the shelves and you could fit other aerosol type instruments in there as well, maintaining high flexibility for the system. Some other accessories that you'll need is for the dryers, you need low dew point air. So Ecotec has a low dew point air source which can provide minus 40 degree dew point air at about 10 litres per minute. So that'll maximise the efficiency of your aerosol dryers. You're also going to need some sort of inlet, whether you already have one. It might be an existing manifold, or it might be a TSP type inlet. And you're also going to need a source of high purity water. Now, maybe you already have that in your laboratory, or you can get something like a milli-Q water system or a milli-pour system for your water generation. Data collection, well, similar to what Grant mentioned before, you could use the Congrego. That's the best option, so you can collect data simultaneously from your 2 Auroras, your wet and dry, as well as your ACS, so it's got the humidity data, and feed it into the Congrego, and in real time you can calculate your scattering enhancement factors and then report it very nicely in using Eridus there. And around the globe there's quite a few installations of the aerosol conditioning system. Some are permanent, some have been used in short-term trials. An example of this is one in Beijing with the Remote Sensing Institute of China, where they're using the ACS to assist with satellite measurements. Same with NRSC in India, where they use it to correlating ground station data with satellite data. And a lot of other systems have been installed and operated here in Australia and in Finland and Switzerland. This is some papers. You can find them on the website that Grant mentioned before if you want to get more details of those. I'll hand back to Grant now.
So in summary today, we've covered an introduction to the Aurora Nephelometer. We said where on Earth it's used, given a number of different examples of the variety of particular applications and conditions it runs in, the principles of the basic principles of operation, how the various options and accessories that are available to make integration to your needs a lot easier, or also covered the aerosol conditioning system, provided details on what that basically is and how it integrates with the Aurora, remembering that it essentially controls two samples in parallel. You can have a wet and a dry, or all sorts of different combinations that you as the researcher can change around what the order is and change your, for different studies you may want to condition the sample differently. It can be set to do humidograms. You can set a number of different points. It's highly controllable from a simple user interface, and it can be used certainly ideally with our nephelometer, but it has certainly been used as well for other instruments in an aerosol basis where you're wanting to look at the impacts of different levels of humidity and the impact on different properties of aerosols. Certainly what's next, you can contact us on the email there. You can visit our website. A really good spot if you're specifically looking for details on the Aurora or the ACS or any of those papers is to visit www.ecotech.com/Aurora.